So thanks everyone for coming to a somewhat different location for this talk. I'm delighted today to be introducing Maarten de Rijk, who is a professor at the University of Amsterdam, where you've been for about 20 years now, I believe. And I've known him for many years now in information retrieval circles. He's done a ton of work in various information retrieval workshops, from Clay to Trek, and covered an amazingly broad set of topics, from document blog analysis, core web ranking, expertise finding, social media analysis, touching some on neural models in information retrieval. But I found out last night when I was reading up on his background that he also had a 10-year career in modal logic. He had a rock star paper there that has almost, a book I guess it was, that has almost 4,000 citations. And about 10 years into his career, shifted to thinking about information access, really broadly considered. And I think it's, I'll find out more this afternoon later about the motivations for that shift. But here, today he leads at Amsterdam a very large lab. I don't know how many students are in it, dozens.
Yep.
And one of the things that I've always valued about students who've worked with Maarten, we have one who did a postdoc with him. I see Julia, many of you know Katja Hoffman. Many others have blessed us with the internships over the many years, is that the students come in with this amazing mix of a strong theoretical foundation grounded in real world problems. And so Maarten historically has done an amazing job of working with various government agencies, local companies, to really educate a generation of information retrieval people who think not just about academic publications, but also asking the right questions. And so today he's going to talk to us. I'm delighted to see this on conversational-based systems, specifically focusing on how people can engage with search engine result pages in a way that is much more than your traditional one-shot search, in and out search. And so, Maarten, welcome, and look forward to your talk.
All right. Thank you for the introduction, Sue. It's great to be here. I think we have about an hour. The main point of this presentation is not for me to reach the last slide, but for you to pick up something. So if you have questions along the way, please just interrupt me and I'll try and answer them. So just to give a tiny bit of background and to follow up on what Sue just said. So I'm a professor at the University of Amsterdam. The title is University Professor of AI and IR, so that means I mostly focus on machine learning related problems that have to do with search, with recommendation, with conversational assistance. The team continues to grow, and not just the technology aspects, but also around the implications of the technology that we help develop. One other thing, and that touches on the second thing that Sue just mentioned, is these collaborations between academia and industry or other non-academic stakeholders. So together with a group of colleagues a couple of years ago, 2 years ago now roughly, we decided that maybe we should structure this a bit more formally, and we founded this National Innovation Center for AI. That's a collection of labs. Every lab is at least 5 PhD students, but in one case it has over 15 students. These are funded by those companies or governmental organizations around a shared research agenda. And the reason we do them is because we think we get better science if we create impact with that science. All these labs are outward focused, so they collect problems with these companies or with these governmental agencies and try to also test their outcomes in those settings. And in many cases it means that the PhD students who work in these labs spend part of their time with these companies or with these governmental organizations. So typically that's 2 days a week. But in some cases, for instance, one of the labs is with Bosch, the German company. They don't have an R&D department in the Netherlands, so the students go to their German R&D departments a couple of times per year and spend some time in Germany in the Bosch labs. And the rest of the time they interact over Skype or phone or short-term visits. All right, so far with our collaboration with Microsoft Research has been sort of a bit more ad hoc. We've actually just one of the students who was funded by a Microsoft Research grant defended 2 weeks ago, co-supervised also by Julia. And my colleague Max Welling, machine learning, works a lot with Chris Bishop in Cambridge. Anyway, that's a bit of background. So the talk that I'd like to give today is based on some finished work, but mostly work in progress. And these are people involved with that work in progress. You know some of them. Maarten was here this summer. I'm here now. And some of you have also interacted with Svetlana, for instance, around TrackCast recently, and Nikos as well. So, in the view that we, the view of IR that we hold in my team is this is all around all about connecting people to information. We don't really care in which way, as long as it's about this, connecting people to information. So sometimes we do have an explicit statement of a need, sometimes we don't. All we have is a profile of some kind, and increasingly this landscape is changing. We're from single shot, as Sue said in the opening, we're moving to multi-turn setups. You probably know these numbers much better than I do, where the sort of queries that are being seen are changing from a traditional desktop setting to other settings. You probably have, as I said, more accurate numbers and more up-to-date numbers than I have access to. But the point here is it's changing in interesting ways. It's changing in ways that to some degree, certainly for IR people, go back decades, right? There are old papers, but for instance by Nick Belkin, going back to the late 1970s, early 1980s, where he discusses at length the idea of search as conversation, multiple terms, with active search, with knowledge elicitation on the part of the system, etc. There was a nice sort of almost position statement and sort of organizing our thoughts around the topic paper by Nick and Philip a couple of years ago. I think that certainly for many IR folks felt like a good positioning of these conversational developments. As you know, a lot of the work that's happening around conversational search is either task-oriented or it's very factoid-ish oriented. But of course, there's more than that. A nice example actually came out of Maarten's internship, which is neither task-oriented in a very strict setting that we know from task-oriented dialogue systems. You know, book a ticket or some such task, nor factoid. These are talking with documents. So the focus there is on increasing productivity, somehow using a conversational agent. And in this case, on the right-hand side, you see an example, factoid QA, given a document. You might want to use that document to answer a question like, what is the capital of France? And then the assistant would have to say, Paris. The document-centered assistant would do something else. You would, for instance, ask it, do we mention our mission statement in this document? Or when did we last update this document? Or so partly about the content, but also partly about the provenance, partly about the metadata of this document. And this is what the assistant would have to say in reply. For instance, yeah, on page 2, and then it extracts some information from the document. And so that work is interesting for a number of reasons. It's a different type of conversational assistant. There's so many things for us to discover there, right? What sort of functionality would people expect from this? What type of questions would they, if they had this functionality, what type of questions would they submit? And on the system side, how can we recognize these document-centered questions and separate them from, say, more traditional factoid questions? Here's another example. That's some work with Svetlana that we published last year. Talk with a data set. So you have a gigantic data set, structured, semi-structured, has a gazillion columns. And now you want to answer questions about this data set. And that doesn't mean you translate natural language questions into SQL or Sparkle. No, it means you slowly reveal the different attributes, the different qualities that are in that data set. And so that model needs to maintain, any model that you would devise for this would need to maintain some sort of a notion of the columns that you've already revealed, how long ago that was, find out whether someone is still exploring or is ready to zoom in on something. Another example, also with Svetlana, that is work on conversational access to very large collections of items. This could be, for instance, the collection of all the paintings that Rijksmuseum in Amsterdam has. And now you want to talk to that collection. What does that mean? What does that mean in terms of engagement? What does it mean in terms of answer format? Sometimes it's, what is it? Do you translate to metadata? Do you translate to maybe visual information? Now, so these are 3 examples of conversational interaction that differ from task-oriented dialogue systems and from more factoid-ish QA. Now, if we go back to another old paper, 2004, Rose and Levinson, Understanding User Goals in Web Search. So this came, I think, 2 or 3 years after André Broda's paper on, in which he proposed navigational, informational, and I think he said he used transactional goals, and then Rose and Levinson called these resource goals. And both papers did various types of analysis, both by doing user studies, but also by doing large-scale classification experiments on how many of the queries that they see are informational. And consistently, it's 40 to 60%. And some of them are very factoid, and so those are the ones that are maybe for this talk I'm not so interested in. Others are much more broader. That wouldn't just be a single entity or a short list of entities that would be appropriate as an answer. But could be different perspectives. It could be sort of guiding users from entities to relations between entities. The Rose and Levinson paper has a number of very concrete suggestions. You can see some of them over here. Directed questions, closed questions, open questions, undirected questions, advice questions, locate questions, list questions, and so on. And so I'm interested in, and we're interested in the broader types of questions that come up here. And of course, we have over the years, we've developed a pretty effective way of returning results in response to such questions. And they offer a lot of richness. They hide a lot of uncertainty. If we're not quite sure what it is that a user is looking for, well, we just give that user a very complex page with many, many options, and then leave it to the user to zoom in on one panel or another. All right, so here I think my example query was Macau or Macau, spelled with A-O or A-U. And then you can see the uncertainty the search engine has in response to this query, right? Things to do in Macau, the knowledge panel, knowledge institutes, questions asked about Macau, etc. And that works in many cases, right? The system doesn't really have to understand what the user is looking for. It just needs to offer sufficiently many options so that the conversation, the interaction, can continue. It's diverse, it's rich, and to some degree, it doesn't get to the heart of the matter, namely understanding what the user wants. So what I'm interested in is this combination. All that richness, all that diversity, all these options, but now conversational. How do we convey this? What is a reasonable response? Macau or Macau? To Macau or Macau? Maybe it's, what do you mean? And so the question that we're pursuing, and directly or somewhat indirectly in quite a few of our ongoing projects, has to do with the bullet up here as the way in which we interact with information changes. How can we support conversations that are as rich and as diverse and as enabling as these complex SERPs, but then maybe in a spoken way, or on a tiny screen, or in a line-by-line chat interface. A warning or spoiler, I don't have the answer. But I do want to tell you, share with you a bit of where we are on this. So as I said, a lot of this is work in progress. Some of it is about to be published in a few months. So let's take a step back and walk through a couple of examples to make this all a bit clearer. Right. So here we have the system, and we're interested in money made by movies. How much money did a movie make? And so we could submit that as a query, and then we would get back a list of snippets, and from one of these snippets we would be able to get back a number, and we don't actually have to be very smart to do that, right? If I remember some of your older works with the early track QA, just a lot of data and knowing what the number looks like is good enough. Another example, a human asking a question, or a system asking a question and then getting a response. What did you think of the title? Well, the title pretty much describes the level of the humor in this Ben Stiller movie. I agree. Do you know if it made any money? Yeah, it made 280 million. Pretty good. Right, so here's our reasonably natural conversation with a system. Right, and it has the answer, and it had the number in red there. It has the answer, but it also has some conversational bits and pieces around it that make it fit naturally in what went on before. Another example. Here we're talking about movie plots. And again, a ranked list of snippets. And in red here, Bond arrives in St. Petersburg and meets his CIA contact, Jack Wade. In a conversational setting. That was a good scene. What did you like about the movie? So, human, system. I liked his friend, Jack Wade. Human. system. I love the part where Bond arrives in St. Petersburg and meets his CIA contact, Jack Wade. Now, again, this feels natural. Why? And it's informative, right? There's a connection in black, and there's a snippet of text extracted from one of the search engine snippets. And so those are the sort of things that that we have in mind when we talk about SERP-based conversations. So a bot that talks to a search engine, looks at the SERP that comes back, that is produced, and then uses the SERP to inform its next utterance. And if you unpack that a bit, what does it mean? So here's the same as before, but now we're unpacking it. We need to fire a query. We need to understand what the question is actually trying to achieve. Then we need to select passages from the SERP that is produced. We may have to summarize those passages and then use this to generate the response. Okay. And so that's richer than a generative model typically is, right? Because that's, we have a document collection, we have a language model trained on that document collection, and then questions come in and responses are produced by this language model. It's a fair bit richer than that, so let's simplify it a bit. Cut out the retrieval step. And just pretend that we have one document given. So we have an ongoing conversation, and then at each term we get one document that we're allowed to use to produce a good utterance, a good response. This has been introduced in the literature just a few years back. It's called background-based conversation. This one document is the background, and you can use it to inform the responses. Okay, so rather than that complex picture that we had with the multiple steps, this is the simpler picture we now have. Conversational history, one document, produce your next response. So here, what is the example? What is a physician's assistant? And then we got some response. And then the next question, what are the educational requirements required to become one? And then the snippet on the right-hand side has this part in blue that says the most common educational requirements are the completion of da-da-da-da, and that is then used by the bot to produce the utterance in blue on the left-hand side. Another example from one of the test sets that is now available, that are now available for background-based conversations. It's about scary movies. And so we have this ongoing conversation of human 1, was it worth money? Human 2, cheesy and trashy, but very entertaining. I bet it didn't win any awards. In comes the background information, that one document that is given, that provides us with background information about Scary Movie 3, various things, award it won, how much money it made, and we also see some additional information, namely there was a Scary Movie 4 and there's a Scary Movie 5. And now, what do different models do that produce responses? Well, a typical sequence-to-sequence model with attention could produce something like this. I think it made an amount of dollars. GTTP, you could check out Scary Movie, 4. So you see a bit of a problem here that the entity is slightly messed up. BiDev, another recent model, has nicely extracted a coherent chunk of text from the background document, but is conversationally somewhat out of place. The ground truth for for this example, in the test collection, has this: you are wrong, MTV Movie and TV Awards 2004 Best Cameo. And so here what do you see? Again, something that fits the answer together with the conversation that went on before, right? You are wrong. It's directly in reply to this. And then the answer. This extracted from the background. So, and that's one of the key challenges in these background-based conversations, namely this knowledge selection. Extract from the background document a good text fragment that you can use in your next response. In the literature, you'll see two types of approach to this problem. One is extraction-based, the other is generation-based. The extraction-based ones simply copy material from the background document into the response. And often what they would do, or the way that they're organized, is they learn pointers to extract, to identify starting points and end points of suitable spans. So here's BIDEF is one example of an extraction-based BBC system, right? It nicely cuts out a good coherent fragment, but it does not have anything conversational. The generation-based ones use the background material to influence the responses that they generate. And they don't always have an easy time using the background information successfully. So often they appear to be fairly natural, but they may break the units extracted from the background. So you see that with GDP here, for example, has a reasonably well-fitting conversational bit here. You should check out, but then it has slightly messed up the extracted bit. Now, we've looked at this problem and tried to understand what's going on here, and and try to understand whether we could improve on what we've just seen: extraction and generation, so as to produce better responses that do use the background. We're not the first to do this. Others have tried to do that as well. For instance, usually these generation-based systems are encoder-decoder based. They often adopt a local perspective, meaning that you generate one token at a time. And then one thing you could do is, for these entities that you've recognized in the background information, simply view them as one token so that you wouldn't cut them up. You either you select it or not, but then you select all of it. Some approaches have tried that. Other approaches have tried to use a knowledge graph in the back, and basically that amounts to the same thing, namely which next entity from the knowledge graph to select and use for your response. So our idea to try and overcome some of these shortcomings here is to complement that local perspective. So what is the next thing that we should generate with a global perspective? And let me try and explain what that means. It's going to be published in early February in a AAAI paper. And so it follows this encoder-decoder idea that most generation-based BBC systems have. So we have an encoder for the background information, that one document. We have an encoder for the context, the conversation that has been ongoing until now. We have something for local knowledge selection, and basically think of that as what is the next token we should generate. And we have this global knowledge selection that tries to understand what the conversation is about and tries to keep track of that. And that global understanding of the ongoing conversation influences the choices that the local knowledge selection will make. So let me explain that in 1 or 2 slides. So first, the global knowledge selection. So at the top here, assume that we have encoded the background knowledge, and we've encoded the conversational context, so what has been the things that have been said until now. We learn a topic transition vector by looking at the relation between these 2 encodings. And that topic transition vector is then used by the local knowledge selection to decide whether or not to go for the next term, or to go from the language model, or to go for the background information. So that's what happens at each decoding time step. The local knowledge selection outputs a response token that's either from the vocabulary, so produced by the language model, or it's selected from the background information. And it's the global knowledge selection module that dictates which way to go. I have a few examples here that I want to show. Let me show this example first. This is our dialogue context. I loved all the tricks and traps. Sorry, I loved all the tricks and traps Kevin created. Human 2, me too. I loved when using a tape recorder, he tapes a message and slows down his voice, placing a hotel reservation. Human 1, that was too funny. The hotel staff didn't believe him though. Here's the background information. Later that evening, he intends to access Kevin's room, but Kevin fools him into thinking that he has walked in on his father, causing the concierge to flee. Home Alone 2 is a carbon copy, but it's also much better and more complex. That's the background. Now, the background-based conversation system needs to produce a response. GTTP, that's a generation-based system. It's a classic, and I watch the first 2 movies every year. Okay. From a conversational point of view, seems to be a reasonably natural follow-up, but it doesn't use the background information. Another generation based approach, RevNet, will also be published at AAAI, by the way, in a few months. That it was so sad when he intends to access Kevin's room, but Kevin fools him into thinking that he has walked in on his father. So we have a mixture here of something generated by the language model and copied from the background, but it's not fluent. It's generation-based again, but only using the local information, meaning basically the language model. I know it was a carbon copy, but it's also much better and more complex a movie than the first. Now, global and local. So true. So here we have a sort of a conversational hook, a conversational link to what went on before. And then a bit of material copied from the background information. Okay, so I hope this illustrates to some degree what these different models do that only have a local perspective versus ones that also have a more global perspective. Now let's go back a second to these. What we have here is at the top, the ground truth knowledge selection, and then the the probability of tokens being selected. So the probability on the y-axis, the tokens listed on the x-axis. We then have that that's the ground truth. We then have the global approach, the global to local approach, and only the local approach. So according to the ground truth, those are the tokens to be selected. The global knowledge selection module is somewhat uncertain. It thinks that there may be some good response here as well as there. That's only global. Global and local together ends up here. And local has various uncertainties, some potential responses that it thinks that are here and that are somewhere further down there. And that's typically what we see in lots of the cases that we analyzed. Uncertainty in the local knowledge selection, uncertainty in just using the global knowledge selection, that's only using the background document, and the uncertainty reduced when we combine global and local. Sure.
How is box 1 selected? I cannot see box 1 and
How this one is selected? Why we selected in this illustration? I have to go back to the paper. I can do that after the talk. The numbers refer to the ongoing the discussion in the paper. Yeah. Now, there's a small number of data sets for these background-based conversations. This is one that was introduced last year. It's built for movie chats. Each response is explicitly generated either by copying and or modifying sentences from the background information. And the background itself consists of plots, comments, and reviews about those movies. And this is collected from a bunch of websites. I think it's IMDb, Rotten Tomatoes. Yeah. And so different types of results on the right-hand side, whether we take a single response as the ground truth or multiple potential responses as ground truth. At the bottom, that's actually more interesting here. So out of all the conversations in the data set, we sampled 500 and then asked human labelers to check each of the system-generated responses for naturalness, informativeness, appropriateness, and humanness. So to which degree does this look like a response that could have been generated by a human? And we did that with 3 assessors per response, for GTTP, for RevNet, and for the model I've been talking about. At least one assessor thought it was natural or informative or appropriate or looked like a human could have generated it, or at least 2. And so naturally the numbers for at least 1 are higher than the numbers for at least 2. On the whole, the numbers for the global and local model are higher than the numbers for earlier models, generation-based models, except for this informativeness. So RevNet is a generative model, and apparently, according to our assessors, it tends to generate slightly more informative responses than the global and local knowledge selection model. Okay, what's next? So remember, this was the simplified picture of background-based conversations. We have the normal conversation on the left, and then at every turn we get one document to help us with the generation of the next response. The original picture was more complex, for SERP-based conversations. And what I'd like to do next is walk you through each of these steps that are numbered there. So search, query understanding, selecting passages, summarizing those passages, and then using those to generate a response. So query formulation, that's the first, right? How do we, from the ongoing conversation, how do we produce good queries that will result in useful SERPs that we can use to generate responses? Now, there's tons of work that you could use, and as a starting point for this, certainly TrackCast this year has work that's immediately relevant here, but there's actually also older work. Last year, 2 years ago, reinforcement learning to generate query reformulations. This is a somewhat older paper, even from 2015. Also, reinforcement learning for producing queries and as the conversation evolves. As the conversation evolves, that means after each turn, you regenerate suggested reformulations, using not just the original query from the user, but also what the user had as a subsequent query, what they may have inspected, what they may have reformulated, etc. Question understanding. So step 2, what is the user trying to achieve in this ongoing conversation? So that's all about trying to infer preferences, likes, dislikes, recognizing entities in the queries, relations between these entities, and in some cases actually learning when to ask an explicit question. For instance, in the Macau or Macau setting, maybe just ask what the user is trying to achieve here. Passage selection. So in some cases, to be able to answer a question or have enough snippets to produce our next utterance, it's not good enough to just have a single document, a single snippet. Sometimes we need to actually go down the rank list of or in the SERP quite deeply. This is a paper that we published earlier this year at Wisdom, also with Hussein, who was here last summer, I think, that does that. Passage summarization, so that's clear that you need this, but there are some interesting new twists here, because perhaps we should do the summarization not in a unimodal context, but in a multimodal context. And also we should, what should we optimize for in this case? Is it to get the best summary, or is it to get the best interaction resulting from the summary? Next step, response generation. So what if we have, we've gone through the whole loop, fired queries, got the SERP, extracted the right passages, summarized them, and now use the summary for response generation. A recurring problem with many of those generation-based models is repetition, the same word being selected over and over again. So lack of, or to put it differently, a lack of diversity. We have some work at www this year that tries to address that problem. Another one is appropriateness. So if you're generating responses, probably you want to avoid adult content, but there are, in many cases, there are different types of things you want to avoid as well. What if it's a sensitive topic and the bot response, I don't care. It's not appropriate in many cases. And so understanding this problem of what is appropriate, what is not, what is a malevolent response, what is not, I don't think we've addressed that, and I think we should. So right now we're trying to build a data set with where we propose a number of categories of malevolent responses, and we should finish that this week. Yeah, this week, and then hopefully we'll be ready with the data set and some classification experiments by the time of ZigIR. I think it's an important problem and not a typical problem that in our community we've looked at. Of course, we've done spam filtering. We've done lots of quality control, textual quality control work at ZigIR, but this is different because here we're generating, and then we should suppress some of the content that we're generating. What else? Right. Right, so as I said at the beginning, we try to not just build technology that connects people to information, but also look at the implications of this technology. And that to make that concrete, that means you look at things like transparency, confidentiality, fairness, explainability in this context has a number of interesting readings. Explainable to whom? If we have this agent that's learning from questions and responses that it receives from users, you might want to be able to trace back why it produced a certain utterance. When did it pick that up? We have a paper at ICML last year that tries to do, that was inspired by this very problem. We see a bot generate a response that is totally off. How did that come about? Some recent work at ACL and only published on arXiv so far tries to use a knowledge graph or some sort of reasoning over entities, relations between entities in a knowledge graph for explanations. And these types of explanations help developers, but could also be used to help users. So what if a bot says something and it expresses an opinion? Should we also try to provide some sort of motivation for this opinion? Here's an example on the right-hand side. How do we do that? Okay. I'd like to wrap up. So the motivation here was for many years we've been using SERPs. There's something fantastic about these complex SERPs because of the diversity, the richness, the sort of a bundling of many starting points on a single page. The motivation was, to which degree and how can we translate some of this into a conversational setting? What I've shared with you is some early steps in this direction, the general ideas, some advances on scaled down versions of the problem, and some challenges and ambitions in the last few slides. There's still a lot to do here, obviously. And here's a whole bunch of references, both old and new ones, that fed into the presentation. Thanks.
You talked about a really complex system that and pointed to different aspects of that system. How do you think about this from an architecture point of view? Like, what is it that you, in building a system, need to put together? How do all those pieces fit together?
Right, so the question was, I talked about a complex system. How do I think about this from the point of view of actually building the system and implementing it? Right, so what we've done with that global to local knowledge selection system was looked at it as an end-to-end optimization, end-to-end training problem. That's great for academic research. It's maybe not immediately the most obvious way to go from a practical point of view, where you would probably want to have a few more intermediate steps where you could intervene if something goes wrong, and you have a better understanding what goes wrong if something goes wrong. This sort of end-to-end versus component-based dilemma you see in many conversational systems. The truth is probably somewhere in the middle. Yeah. Matt, you had a question?
Yeah, so I don't know if I fully understood. Could you talk a bit more about how you envision the interaction between the conversational chat part and the SERP itself? Like, are these affecting each other, or are you replacing the SERP with the conversation completely?
Right. So we no longer see the SERP. We knew it once existed.
Okay.
But we knew it offered an incredible richness of information, and it could also hide a lot of uncertainty of the search engine. But it didn't need to make a choice, as long as it offered enough starting point for a user.
Yeah.
Now we no longer show that to a user. The user just talks to a device. Could even be this device, and I don't know. But we do want to convey all that richness that was originally in the SERP. Maybe that was the wrong answer, or maybe it's there indeed. Could also be, you guys. And so, how do we convey some of that richness, some of the diversity? How do we circumvent the fact that we can no longer be as uncertain as we could allow ourselves to be on a SERP?
Okay, but you're talking about completely replacing the
Yep.
SERP with the conversation.
Yep. Right.
From your title, the SERP-based conversation, and the way that you present the query generation for search engine, I have the feeling that this is a conversational interface to a search engine. So my question is, do you think that for a broader setting up conversational information seeking or conversational search, do we need to only build the conversational interface on top of an existing search engine, or we need to also design that search engine? Do we need to change anything inside that search engine?
Certainly, we need to change things in that search engine. If you go back to, sorry, the question was, do we need to, is it right to say that what I've been presenting is just a conversational interface to a traditional search engine, or should something else happen? Now, if we go back to Matt's question, my answer to Matt's question, how do we deal with the uncertainty and resolving the uncertainty? Now, today, we don't really have to estimate how confident we are with the results from one vertical versus the results from another vertical. We just show both of them. And of course, they have probably a ranked list or some order in the panels from these verticals, but hey, we don't need to align this. In this conversational setting, where we have one response at a time only, no, we do have to have a global confidence measure, a global sense of certainty or uncertainty across the results that we have. So that has certain implications. Maybe, certainly in a more traditional federated search, you don't actually have to align the confidence values across the verticals. No. So that would be one example. I also think that another important aspect that has to change is understanding the implicit feedback, interpreting it, also being more proactive and understanding how and when to do this. If you do it too often, people will get fed up and it's not helpful. But you should probably do it more often than we do it with a traditional SERP. Yeah, I think you were first. Yeah. Yeah.
In the current mental model of searches, a user is faced with multiple documents they have to choose from.
Yeah.
Right, and they may then prioritize given a sort of algorithm, etc. But what do you think is the right mental model that you would like to have? Are you interacting with a broker of information that will disambiguate and reconcile potentially contradictions between documents, or do you want to know that there are multiple documents? What do you think is the right mental model in this new paradigm of interaction?
Okay, so the question is, what is the right mental model here? Is it a broker that decides for the user or that displays some of the uncertainties? Yeah, I think that's a great question, and I don't have the answer. I'm moving back and forth between this traditional, almost librarian information intermediary model on the one hand, and someone who would give me more control myself and says, well, I don't know, here's some options. Of course, for some things, you want to be in control, so you want to be on this side of the spectrum. Share the uncertainty with me so that I know about this. In other cases, I don't actually care. Just give me a reasonable result and then I'm ready to move on. And so maybe that's another part of an answer to Hamed's question. Where should we be? In which cases? And for which type of information needs? Yeah. You?
My question was very similar, so maybe it's already answered. But it was just this notion that you mentioned that when we move to conversation, it's more difficult to hide behind like the uncertainty needs to be resolved in this resolution. But there's also uncertainty on the user's part. And
Yep.
I'm just trying to understand sort of how the user can navigate this space through conversation when they themselves have a lot to learn about what's out there. So I think it's very related.
Yeah. Yeah.
How do we an overview of the information space? All in on this.
Yeah, so I don't have the answer to this. We've experimented a bit, for instance, with talking with a gigantic data set where you simply cannot enumerate all of the columns in the table or in the very large cultural heritage collection. You cannot enumerate thousands of paintings, right? So what do? So there, what we actually fell back on after a while was, a person can probably remember 4 to 6 items, and so we'll give them 4 to 6 items at most at a time. And then if we feel that we need to go back to enumerating items, depending on how long it's been since we last enumerated some items, we either repeat some or we don't. And so these are very basic cognitive heuristics, but yeah, that's where we are at the moment. Nick.
Just a comment on appropriateness. I love that concept concept, and actually in Bing we have a lot of this where we feel like if we return something inappropriate, someone can tweet it. And there can be really, really bad cases.
Yeah.
So, like, appropriateness is this really interesting thing. It's more of a comment, just that I love the notion of appropriateness, and it's actually one where you're sometimes in danger almost.
Yes. Yeah. And yeah, I mean, we've it's totally unclear what to do in many cases. So you've had this anti-vaccination or not discussion here. We've also had it in the Netherlands, and so at one point, one of the e-commerce sites that we collaborate with in response to a query about vaccination only showed across the fold, I think, anti-vaccination results. And so someone took a screenshot and tweeted, and this e-commerce site is totally bonkers, or whatever the words were that they used. And well, no, because a bit further down on the result page there were results displaying a different perspective on the topic. Well, yeah, what do you do? It's once the tweet is out there, you're lost. And so, what do you do then? Yeah, if you think if it's your value to show diverse results in such cases, then maybe you should even, that should not be one perspective above the fold, the other below the fold. Always you should see the diversity, apparently, right? And that's what they decided to do in response to this. Make sure that there's always, if there are multiple perspectives, always show them, even on a small screen.
Let me ask maybe a final one. What do you see as the big open research challenges in this rounded conversation?
It's probably this question that you asked already. We can probably get to reasonably well performing end-to-end trainable systems that go quite some way towards the goals that I outlined. Now make them real. Make them real with all of these bells and whistles that I mentioned, with the appropriateness filters, with more of a pipeline-based approach. So it's taking these ideas, well, first growing them further, but then taking them out of the lab. Yeah. Oh, we have one more question?
Yes, but I can also take it offline. So in the majority of the work that I accompany, so they're called dialogue generation, but because there's not much planning as to how the conversation is going to go multiple rounds, it's mainly like a matter of like response generation.
Yeah.
Anything, etc. This is what I generated. It's basically like a single, not really dialogue in the sense that humans plan, like I'm going to get to that factor if I would ask that.
No, and I agree. And so in many cases, viewing this, well, so far at least, as a planning problem is overkill. And in many cases, you can get by perfectly fine without reinforcement learning. Just treat it as a classification problem or a hierarchical classification problem, perhaps, and that's it so far, because of the limitations that our data set and our evaluation measures have. Yeah, good point. All right, thank you.